Hello, this is Bora taken from Data Analytics class. Welcome to my image classification presentation. In this video, the problem we have will be defined. Given training and testing datasets will be inspected. After that, I will talk about three different models I used to solve the problem. Then I will be comparing the models I used. At the end, I will talk about the major takeaways from the project. For the classification problem, we have 19 different classes. There are animals, people, objects, vehicles with different patterns. Our goal is to classify them properly with high accuracy. In the dataset, we have approximately 130 training images for each class and 30 test images for each of them. The images are in different sizes, different image file formats such as JPEG and PNG, which requires to fix their sizes because the pattern of the algorithm should be equally affected from each image to give proper results. Also, we have a CSV file containing the ground truth table for the test images. For one of my approaches, I decided to use convolutional neural networks because it is mentioned in the class that CNN gives one of the best results for image classification problems. Another reason was my familiarity with the concept. Also, I knew that CNN is one of the most used deep learning algorithms in the image classification due to its accuracy, so I decided to use CNN. Firstly, I tried different numbers of layers and I resized images to 150 to 150 pixels and applied a very similar approach we used before. I ended up with poor accuracy. Then I increased the number of pixels to 250 to 150 and I got very high results, which we will be discussing in the next slides. After having that high result, I even tried to increase it a little more. However, Google Colab couldn't run the code due to its high RAM usage. To my convolutional neural network, I applied many different approaches, changing colors, rotating some classes, adding or deleting some layers. But as I mentioned, the key point to increase the accuracy was to resizing the images to 250 to 250 from 150 to 150. It increased the accuracy by almost 8 times because it increased the number of details in each image and the algorithm consistently detected the patterns in the classes. I saw that the quality of the data can positively or negatively affect the algorithm's performance. On the slide, my last approach can be seen. I almost got 97 accuracy in 2 hours. In terms of the results I got, which is quite impressive, we can say that the data we have is complex, but the deep learning algorithm learned the pattern of each class properly. As some other approaches, I used support vector machine and support vector classifiers. I had similar experiences for both models. I tried all kinds of things as I tried in CNN to increase the accuracy of the models, but the accuracy didn't increase much. I saw the major problem with the models were that the predictions they made were highly biased. In other words, almost all of the predictions were coming from 2 to 3 classes. I couldn't get any meaningful results from these two models. In terms of the training time, they required very little time to train compared to my convolutional neural network approach. I believe the reason of the low accuracy is the complexity of the data. After a little research, I saw that support vector machine and support vector classifiers don't perform well with the large datasets. My conclusions with the project. First, for the given dataset, I can say that convolutional neural networks perform better for complex datasets compared to support vector machine and support vector classifiers. Second, data augmentation improves the accuracy, but the key factor is selecting the model properly. Third, if the predictions are biased on few classes, making changes in those classes can increase the accuracy, but as I mentioned before, it is not as effective as choosing a proper model for the given dataset. My last takeaway point is that it is important to know what kind of model should be used for the given datasets. It saves too much time and makes the applications easier. Thanks for watching my presentation.